All right. So with our sine functions, these 5 key points are going to be pretty much ingrained in your brain by the time we're done. Okay? It's going to be the same pattern over and over and over again. All right? So sine of 0 is what? Sine of pi over 2. Sine of pi? 3 pi over 2? And 2 pi. Okay. So we're going to graph those. All right? Starting here. Then we're going to skip pi over 4 because root 2 over 2 is really makes no sense. These are your key points you want to remember. Okay. And one thing with the sine curves, they're really smooth curves. Okay. They're smooth curves. Right. So, if you look at this sine graph, okay, and compare it to a Ferris wheel, okay, sine graph compared to a Ferris wheel, okay, what would the x-axis represent? What do you think? What would the x-axis represent for the circle? What do we think? What are some comparisons there? Do you know? The time it takes to complete one revolution, okay? One rotation, right? Anything else? Yeah, no. The starting point, excellent. So this guy right here in the center, okay, we always start at what's called the midline, okay? Midline is the center of the circle. It's our radius, our diameter actually, okay? It's the center of our circle, all right? Now, what did you notice in terms of our domain? How many of you said when you did the full, okay, full graph, when it kept going, negative 180 to 720? Okay, at first, right? But then if you looked at the key, I had negative infinity to infinity, right? Because this is ongoing in both directions. Even if I was to go on the negative side, it's still ongoing all the way through, okay? What about the range? What was the range? Yeah, Braden. Negative 1 to 1. Well, negative 1, or positive 1, I should say, the distance from the midline to the maximum point, the midline to the minimum point, is called the amplitude. Okay? It's the height. Think of it this way. From the center of the circle to the top, this is the amplitude, which, as we just stated before, can change depending on the height of the circle. Okay? So those are 2 key words for you to remember. One thing about the amplitude, it's the vertical stretch, and it's always positive. Okay? Think of a number in front of a function, right? If it was greater than 1, it was a stretch. If it was between 0 and 1, what was it? Compression. But the negative meant what? Reflection. That's the same thing here. So if you see a negative sine of x, the amplitude is still 1, but there is a reflection. Okay? So the amplitude of the graph above is 1. Okay? And it's the distance between the midline, which is the middle of the graph. In this case, it's y equals 0. Okay? To the top. Now, for our basic sine graphs, one complete rotation happened in 2 pi, which is called the period. Okay? The amount of time it takes to complete one full rotation. So from 0 all the way to 2 pi. Okay? That's how long. However, that could change. Think of the time on a Ferris wheel. You could have 15 minutes, or you could have, let's say, 10 seconds. Okay? Depending. 1 full rotation. That can change, and that is called a period. Okay, so some of these letters might look familiar in terms of A, okay, C, or D, okay. We saw those with A, H, and K, same scenario, okay. A, H, and K, these are very similar to A, H, and K. We're only going to look at, and I might show you some extensions, but using A, B, which is new to us, and D, which is the same, okay. Turn the page. Okay. This reiterates, okay, what the amplitude is if there's a transformation, okay? So amplitude, vertical stretch, or compress, it's always positive, okay? It's the distance from the midline to the top and midline to the bottom, okay? Right? If it's negative, it just means reflection, all right? So if you think of our y values, they're 1, -1, 0. If it's a reflection, those positives become negative and those negatives become positive. All right? So what we're first going to do is, for this first graph, we're going to do 1 and -1. We are going to graph our parent function first. Okay? So our midline for the parent function is 0. Okay? It's the center of the graph. The amplitude, okay, of the first graph is 1, because there's just 1 in front, right? So in blue is going to be my parent function, what we just graphed on the first page. Okay. Now, looking at g of x, what does my amplitude change to? Saying 1/3, okay? Our amplitude, the number in front, is now 1/3, okay? So, you always, if you have a new amplitude, you start from the midline and count up 1/3 and down 1/3, okay? My midline for this graph is still 0, and it's still following the same trend. So starting at 0, now we're going to 1/3, we're back to 0, -1/3, and back to 0. Okay, so by our amplitude changing to 1/3, you hopefully saw a compression. Okay, does that make sense? Okay, so now in number 2, okay, they both don't have anything added or subtracted to it. So our midline is automatically 0. We're going to see examples where that changes, but it automatically is 0. Right? So our parent function, sine of x, okay, 1 and -1, graph your parent function. For our new function, -5 sine of x, what is our amplitude? Yeah, Taylor. Careful. Careful, careful. 5, okay? The amplitude is always positive. What does the negative mean, though? Reflection. Good. Excellent. Okay. So, since our amplitude changed to 5, okay, you go from the midline, and it's 5 above and 5 below. The midline is still the same at 0. Okay? For sine functions, you start at the same spot. You're still at 0. At pi over 2, where would we be now? Louise? Excellent. -5. At pi, we're still at 0. At 3 pi over 2, where would we be? Liam? +5. And then back at 0. Okay? So the reflection goes down first instead of up. All right? Try the third one on your own. All right. What is our amplitude? Yeah. 2. Our midline is still the same. Okay. 2 and negative 2. We still start at 0. Pi over 2, where would I be? What value? Yeah, Addison. 2. And then where? Good. Yeah. Perfect. Awesome. Okay. So amplitude changes the shape. Okay. It either stretches or compresses. Okay. Good. Yep.
So for that one, do we need to run the calculator? We just make probably
Either way, if you did both, that's fine. Okay. All right. So now we saw this a lot with functions. Okay. Vertical shift. If it's outside parentheses, like we see here, you're either moving up or down. Okay. You're either moving up or down. So that's where your midline changes. Right. So outside means your midline. Okay. In front means your amplitude. Okay. So what is our midline of this function? We're going from 0 to what? 3. Okay, our midline is y equals 3. So we're at 3. What is our amplitude of this function? 1. Our amplitude is 1. So what that means is, from your midline, you count whatever the amplitude is. So 3 plus 1 is 3 minus 1, 2. So your graph is going to be between now 2 and 4 instead of negative 1 and 1. Does that make sense? Because we shifted everything up. So with this graph, sine, where are we starting? Yeah, Liam. 3, 0, 3. And pi over 2, where do we go? 4. Pi. 3 pi over 2. And 2 pi. And here's your graph. Okay. Right? The parent function is always going to be your midline, your max, your midline, your min, your midline. Okay? The same pattern. Right? So for number 2, yeah. Nope, same thing for cosine. Right. So for sine of x minus 1, where's our midline? Careful. Negative 1. Our midline is negative 1. What is our amplitude? Do you know? All right, amplitude is equal to 1. So negative 1 plus 1 is what? 0. Negative 1 minus 1. Okay. So now we're between the bookends of 0 and negative 2. Okay. Where do we start? 0, negative 1. Then where? 0. Then? Awesome. So if you notice, it follows the same exact trend over and over again. Your midline, your max, your midline, your min, your midline. If it's a reflection, your max and min switches. Okay? Try number 3. Line. Keelan. Negative 1/2. All right. What is our maximum? 1/2. Good. What's our minimum? Okay, where do we start? 0, 1, negative 1/2. Then where do we go? Pi over 2. Where do we go? Pi. 3 pi over 2. And then, good. All right. So the last thing for today is tying both of those two things, which you kind of already did, together. Okay? We kind of already did that together. So you always want to start with your midline first. Okay? You want to start with your midline first. And looking at number 1, what is our midline? 1. Our midline is 1. Okay, what is our amplitude? 3, 2. Okay, so that means from your midline, you count 2 above and 2 below. So 1 plus 2, 3. 1 minus 2, just fall out at this point, -1, right? Okay, where do we start for our sine functions? 0, 1. Then pi over 2, where do we start? Where do we go? Sorry. 3, 1. Keep going. Yep. Good. So it might help, one piece of advice. It might help drawing your midline, because I can't tell you, I do it too. From here, I sometimes go to 2 pi. So make sure your midline is drawn. All right? And number 2, the last one for today. What's our midline? -2. What is our amplitude? 1. So from -2, add 1. -2 minus 1. Okay. Now, where am I starting? -2. Okay. Pi over 2 is where? Good. Pi. And 3 pi over 2. And 2 pi. All right. Awesome. Okay. Great. All right, you guys.